Good morning. So good to see you here. Happy Earth Day. I'm more than thrilled to be here. So I want to start out by saying that over the past 10 years in doing research in Antarctica, there's one thing that I've learned, at least one thing I've learned, and that is doing research in Antarctica is not easy. As a matter of fact, there are so many questions that go unanswered, not because we don't want to, but because we simply can't. So take, for example, the Weddell seal, which is this unreasonably adorable creature you are looking at right now. This happens to be one of the best studied marine mammals on the planet. And that is because there is one population at a place called Erebus Bay that has been studied and visited by field crews in perpetuity since 1967. And the reason that can happen is because it's right next to McMurdo Station. It's very easily accessible. Virtually everything we know about Weddell seals comes out of Erebus Bay. But what that means, on the other hand, is that the remaining 11,000 miles of coastline is completely inaccessible, and we know nothing about how seals happen to be doing. And these are very important indicators of climate change and of the health of the Southern Ocean. And so, taking that into account, in addition to the effects of climate change and the potential effects of a fishery, and we're getting to a pretty big problem here. How do we know if we're having an impact on the Southern Ocean and on Weddell seals if we simply can't get to these places? Because Antarctica is inaccessible. It's too dangerous and difficult to get basically anywhere to be able to study these species. And so that's a problem for somebody like me who is interested in learning about how these seals happen to be doing. But the fun part about being a scientist and about some of the things that I do is that I happen to be up for a challenge. But what's even better is it turns out you are too. So what I want to talk about today is how persistence and creativity and coming together as a sense of community is, for the first time ever, allowing us to address this previously unanswerable question. And we are being able to look at how Weddell seals are doing around the rest of Antarctica. So my foray into doing research on Weddell seals happened entirely on accident, and this is true. In the summer of 2009, I was working as a cartographer with the United States Antarctic Program, and I happened to be making a map of Erebus Bay, which is in this blue box on your screen. And at the time, I was using this really new and cool resource called high-resolution satellite imagery. It's exactly the kind of images you would see on Google Earth. So you can see like cars and stuff. It's very, very fine detail. And as I was making this map of Erebus Bay, I came across what Jill Berger said yesterday was perfect black blobs on white. And I got quite excited to see these black blobs in that circle right there. And I kind of thought I knew what I was looking at, but I wasn't entirely sure. And the best part, or I guess the nice part about being the cartographer with the United States Antarctic Program is I had everybody's email addresses because I was making the maps. So I shot off several emails, and within probably a half an hour, I got them all back, and they're like, yeah, those are seals, Michelle. You were looking at seals from space, which I feel like is a really bad, sci-fi movie. And so I got really excited. I'm like, oh my God, this is so cool. Like, I'm looking at seals on an image that was taken hundreds of miles in space. That whole inaccessibility problem can go away if somehow we can deploy this kind of imagery and use it to get to these inaccessible places. And so from that point forward, I decided, okay, time to do a PhD. I'm going to go and do this because that sounds like a lot of fun. So as a new PhD student doing a conservation biology program, one of the first things you do is you start reading. And because this particular seal species has been studied for so long, there is a lot of reading to do. And so I learned about how deep they can dive, which is around 2,000 feet. I learned that they can live up to 30 years. And then I started figuring out what they eat. And as you might imagine, they eat Antarctic toothfish and lots of other fish. But this is a particularly important fish in the Southern Ocean. It's very, very critical for the health and function of the Southern Ocean food web. Because not only is it a prey item for what else seals and orcas, but it's also a predator in and of itself. And the thing about Antarctic toothfish is that it is this big, fatty, nutritious, and also buttery and delicious fish. And if you want to know why I know that, if you don't recognize the term Antarctic toothfish, perhaps you do recognize the term Chilean sea bass, because that is how this fish ends up on our plates at high-end restaurants around the world. So to allow me to connect the dots for you, we are literally competing with wet-ell seals for food that they require to survive. And it was at this point, when I had had several discussions with people who know far more about this fish than I do, when I realized that the project that I had taken on turned for me. It wasn't just a cool new thing that I had literally stumbled upon. Now I had a sense of urgency, and I had a really good reason to try to figure out how these seals are doing before we have an impact, a negative impact, that we can't undo. So I got to working on counting seals as fast as I could, and I realized also very quickly that, okay, be smart here. How can we do this? I'm only one person. I'm going to try to automate this in some way, have the computer do some of this for me. And so I worked with a computer scientist who is a good friend of mine, and we got to work pretty quickly on trying to have a computer detect the seals for us. Which sounds like a fantastic idea, but it didn't work at all. It was miserable. What ended up happening is it found the seals, which was great, but it found all kinds of other things too that aren't seals, because apparently there's all kinds of other things on the landscape that look black and like big blobs, like shadows and melt pools and rocks. And to further deflate my balloon in trying to do this quickly, the time it took for me to train the computer and run the algorithm was 20 times longer than it took me to look at images just myself. So in other words, I was kind of back to square one. Like, all right, so a human has to do this. So far, I am that human. All right, so here we go. So then that remained for quite some time until I told that very story to some colleagues of mine at Digital Globe. Now, Digital Globe is the company that owns all of this high-resolution satellite imagery. And so I was telling them this story, and he said, you know, you should call TomNod. I was like, what's a TomNod? So I got a hold of a guy named Luke Barrington, who was the co-founder of TomNod. Now, TomNod is an online crowdsourcing platform that allows anybody in the world to access this high-resolution imagery and look for stuff on it. It's like, well, that sounds pretty great. So Luke and I got together, and we had a couple conversations, and we decided that we should write a grant together. And so we did, and to my shock, a year later, we were funded by the National Science Foundation to look for seals using TomNod, which was great and exciting, and then I had that dreadful feeling like, oh my God, now what? Because no one had ever done this before. No one had ever used high-resolution imagery and citizen science to do wildlife ecology. We had no idea what to expect, and I remember distinctly sitting in this beautiful boardroom that Digital Globe has, and sitting with my team, and we're trying to figure out how long this is going to take and how many people we're going to need to be involved, and we had literally no idea what we were doing. And so literally after 2 days of deliberation and trying to strategize, we said, you know what, we just threw up our hands and we said, we have to give it a shot. We have to try and just see what happens. And so last summer, we decided to do a pilot project, and what we found was astounding. The response we got was astounding. Over the course of 50 days, we had 5,000 people help us tag 3,500 seals, covering an area that would take more than a decade of a field crew to cover. And what's more is it was done seven times faster than I could do myself. This was absolutely amazing. As a matter of fact, we had to shut down the campaign because too many people were doing this. We couldn't keep up with the imagery. It was absolutely astounding. But if you want to know what inspires me, it's not just the response we got, it's this image. This is a picture of a high school friend of mine who I hadn't talked to since high school, actually. This is her daughter. And she heard about our project on the radio and decided that she wanted to help Antarctic researchers do their science. The fact that this young lady is empowered enough to help me, to help us understand what's going on in Antarctica is incredibly inspiring, and it fills me with so much hope because anybody can do this. You don't have to like to get cold or be a professional scientist. If you have a curiosity and you have a will to help out, you certainly can, and I think she is a great example of that. And so really what I've learned since doing this project is it's not only that things are difficult in science in general, and particularly in Antarctica. Through persistence and creativity and coming together as a community, despite the fact that this community is very big and online, we can come together and answer some of these really interesting and really difficult questions. And for the first time ever this year, we will be able to figure out how many seals there are in Antarctica, how those populations are doing, and hopefully we'll be able to do it before climate change has an impact and before it's too late. And I hope you'll join us. Thank you.